Hi, welcome to Dr. Raz, the Baking Chemist, on this another cold, miserable, rainy day. But just perfect weather to do chemistry, isn't it? So today's question is another multiple choice question. This time it's on ideal gas equations. The key, as I said in my thumbnail, the key to these multiple choice questions is to find a quick and simple way to do them. In this video, I'll be showing you the quick and simple method to do this multiple choice question. But I will also be showing you the background why this quick and simple method works. And also, I will be showing you a much more detailed method of doing this question, just in case this question comes up as a structured question. Now, you don't have to watch all of this video. I will put chapters in my description below, so you can jump to whichever method that you need. But I think you probably should watch the entire video just so you do know the background of this ideal gas topic. But anyway, let's see what we can do. Right, so the question is 130 centimeters cubed of oxygen and 40 centimeters cubed of nitrogen, each at 298, so 130 centimeters cubed. Now notice, I'm talking about ideal gas equation, and immediately I'm thinking, oh, centimeters cubed, need to be aware of that. 40 centimeters cubed of nitrogen, okay, so that's oxygen and that's nitrogen, each at 298 K and 100 kilopascal. Well, that's a sort of a normal conditions for ideal gas equations, so that's okay. Were placed into an evacuated flask of volume 0.5 decimeters cubed. So here they're giving me decimeters cubed, here they're giving me centimeters cubed. Immediately my mind is on alert, on alert. I need to do something about it. What is the pressure of the gas mixture in the flask at 298? Well, the next thing that's going in my head is, okay, well, the temperature is the same, okay? And they're looking for what is the pressure, okay? Now, all the answers are in kilopascals, which is the standard units for pressure in ideal gas equation, so that's okay. It's obviously 1 mark and it's multiple choice. So what is the pressure of the gas mixture? So it's not individual gas, it's the total gas mixture. Let me show you the quick method. All right, now quick method and the background. If you want to know the background, jump to the relevant chapter. It's in my description below. So quick method is P1 V1 equals P2 V2. And so initial pressure times by initial volume equals to final pressure times by final volume. Now they're giving me the initial volume. Obviously I'm going to have to sort of change the units and then add it together, but they're giving me the initial volume. Okay, the initial pressure, yes, I know the initial pressure, that's the initial pressure, and the final volume they've given me. So the final volume they've given me, initial pressure, initial volume, and of course they want the final pressure. All right, so let's work out the total volume in decimeters cubed. All right, so the volume of oxygen is equal to, in decimeters cubed, is 130 divided by 1000. If you don't know how to convert centimeters cubed to decimeters cubed, where have you been, right? So 130 divided by 1000, so that's 1, 2, 3, so it's 0.13 decimeters cubed. The volume of nitrogen is 0.04 decimeters cubed. So the total volume is equal to 0.17 decimeters cubed. All right, so I have mine now, total volume. Right, pressure. Okay, so what I'm going to have to do is I'm going to have to rearrange this for pressure. All right, P2 equals P1 V1 over V2, and I'm just going to slot in the numbers now. Pressure, initial pressure is 100 kilopascals, that's in the question. All right, times by, and of course it is kilopascals, times by the volume, which is 0.17, divided by the final volume, which is the 0.5 decimeters cubed. 0.5 decimeters cubed, and that equals 34. So the answer is 34. And that's another thing, people. Learn how to fill in multiple choice questions. You color in the dot, the circle. You color in the circle in the center. You don't color in the whole thing. You don't put a cross. You don't put a tick. Come on, right? And of course, while I'm at it, just in case you don't know what to do, oh, I've changed my mind. It's actually not C, it's actually B. So what you do is you cross that whole square out, and then you know, just one simple cross, and then you circle in the correct answer. And then you think, oh, no, I'm actually right. I was actually right here. Then what you do is you cross that square out completely, and then you circle the whole square, including your cross. All right. Learn how to fill it in, right? Because these are marked by computers, yeah, usually. All right, it's easier for them. Okay, so the answer is 34. Now, why does the system work? Why does this, this P1 V1 equals P2 V2 work? All right. If you don't know the dilution equation, all right, you know the dilution equation, yes, C1 V1 equals C2 V2. Let me know in the comments, and I'll explain that in another video. Okay. However, the reason why this works is for the following reasons. All right. You know that the ideal gas equation is PV equals nRT. They've said to you, T, temperature, is constant. Temperature doesn't change before and after. So that temperature is constant. R we know is 8.314, and that's constant. Okay. Moles is not changing from before and after. Okay. So they're not changing the moles. Okay. So that means that's constant. In other words, this expression, when you take P and V for the oxygen, let's say, that is constant. In fact, in this case, you can take the P and the V for both oxygen and nitrogen. It's constant. It's the same. Okay. So you know PV is constant. That means the PV should remain the same before and after. So the product of PV should remain the same before putting into that new container and after putting into the new container. In other words, what we're saying is that if V increases, P should decrease. If P increases, V should decrease. In other words, PV equals constant. And therefore, I can say, well, if I take the initial pressure and the initial volume, it should be equal to the final pressure and the final volume. So the reason why this works is because there's no change in the moles. Then there's no change in the ideal gas constant, and of course the temperature is the same. That's the reason why this works. It doesn't work all the time. Why? Because let's say they changed the moles. They said, okay, we had this many moles of oxygen and nitrogen before, now we're going to put this many moles. Then you know that that's not going to work. Okay, and then of course there is a way of doing it. Then you can move that across and say, right, PV over N is constant. But anyway, that's a different story altogether. All right, this is why this P1 V1 equals P2 V2 works. All right, just very similar to the C1 V1 equals C2 V2. All right, so this is the background of this quick method. A bit longer method, right? Now remember, in a multiple choice, if you do the longer method, which is what I'm about to show you, then you're not doing it right. You're wasting time. You'll get to the right answer, but you're wasting time. Yeah. Remember, you only have like just under a minute and a half to do these multiple choice questions. Yeah. So you can't be spending a lot of time. Okay. Right. As you can see, I mean, when I got to this answer, I did get to this answer within 30 seconds. Yeah. I mean, literally total up the volume, convert it into decimeters cubed, total it up, put it into this equation, 34. There's your answer, right? Okay. The longer method. What you could have done is this. You could have said, work out the moles for each of the gases, right? So work out the moles for each of the gases. Okay. So it's PV equals nRT, and this is going to be for oxygen. N equals PV over RT, and therefore pressure is 100 kilopascals. Remember, 100 kilopascals times by, so oxygen volume is again in decimeters cubed, so it's 0.13 because it's decimeters cubed in the ideal gas equation, and divided by 8.314 or 8.31 is fine, and then times by 3 sig fig, isn't it? Yeah, they've given you like 3 sig fig there, 2 sig fig there, and 2 sig fig there, so, or 3 sig fig there, so it's 3 sig fig is fine. Okay, and then temperature is 298, and then you literally work it out. Please learn to use brackets when you're using these kind of things, yeah, on a calculator, or work it out. So 100 times 0.13 equals, and then 30, and then divide that by, and then you use the brackets, people, yeah, because often people don't use the brackets. So the answer is 5.250 times 10 to the minus 3. Okay, and that's moles. And that's moles of oxygen. All right, I now need to work out the moles of nitrogen. So the moles of nitrogen is, again, PV equals an RT, so N equals PV over RT, which equals, again, pressure still the same for this gas, kilopascals times by, now this time the volume is 0.04 divided by 8.31 times by 298, which equals 1.615. Now I'm in between an answer, final answer, so I'm going to leave it to more significant figures that I actually need for my answer. Okay, So that's why I'm giving it 4 sig fig. Fine. If you still don't know about the significant figures, I've done a video on significant figures. Yeah, it's free on molecules, but part of that video is all about significant figures. Okay, you might want to have a look at that. So you've got the moles of oxygen, you've got the moles of nitrogen, and now what you do, you work out the pressure for the oxygen, the pressure for the nitrogen with a new volume. Remember, total volume with a new volume, and then you add up the pressure. So yes, this is long, yeah, but remember, you know, if this question had come up as a structured question, you could have been forced to do it this way. All right, so here we go. So now the pressure of oxygen. So moles, we know the moles of oxygen now is 5.25 times 10 to the minus 3, okay, times by 8.31 times by temperature, which is 298, divide that by volume. What is the volume? Now the volume here is the new volume. Okay, so that equals 26.00. Yeah, 4 sig fig, and that's the pressure, and that's of course in kilopascals, because remember I've used all the normal units. Yeah, so this is in kilopascals. Now you do the same thing for pressure of nitrogen. 3 sig fig is 8 kilopascals. And of course now when you add up the total pressure, remember it's the total pressure, isn't it? So it's saying the gas mixture, so I need the total pressure. So 26 plus 8, which equals 34. So that is your answer. Okay, and of course again you get 34 answer. So what I've done is, just to summarize, is I've worked out the moles of each of these gases, and then I've used those moles to find out the pressure, yeah, for each of those gases, and then I've added the pressure together to get you 34 moles. As I say, it's a longer, yeah, method, but they could have given you as a structured question, yeah, and they could have said show, yeah, that the pressure of the total mixture is 34, and that way you would have had to do this. Yeah, there is another way of finding out moles, yeah, of each of these gases. Okay, and let me show you that now using volumes. Okay, so using volumes. So you should know, and if you don't, now you will, right, that 1 mole of any gas, 1 mole of any gas occupies how much? 24 decimeters cubed. You know, so 1 mole of any gas occupies 24 decimeters cubed. So if you know that the volume of oxygen is 0.13 decimeters cubed and 0.04 for nitrogen, you could actually use that to work out the moles, right? So watch this, yeah, oxygen, moles of oxygen, right? So volume of oxygen is equal to 0.13 decimeters cubed. So if 1 mole occupies 24 decimeters cubed, well, how many moles will occupy 0.13 decimeters cubed? Okay, so this is a simple sort of ratio, isn't it? Yeah, so you say I want 0.13 on this side, so I'm going to divide everything by 24, so 24, okay, and then I'm going to multiply it by 0.13. If you don't know what I'm doing at this point, with this particular situation, ask me. Okay, so this is going to be moles, yeah, so that divided by that times by 0.13, that'll give you moles. 0.005416, and that's the moles. That's moles of what? That's moles of oxygen. Okay, in a similar way, I'm now going to find moles of nitrogen. 0.0016 decimeters cubed, and this is actually 6 reoccurring, yeah, so I'm going to put it to 7. And now, so I've got the sorry, that's not decimeters cubed, that's moles. So I've got the moles of nitrogen, I've got the moles of oxygen. Remember what I'm trying to do, I'm trying to find the moles, yeah, and then what I do is I transfer this moles into my pressure equation. Okay, so pressure of oxygen, there's the moles, pressure of nitrogen, there's the moles, and I'll work out the individual pressures. So this is just another way of finding moles from the volumes, yeah, knowing that 1 mole occupies 24 decimeters cubed. So once you find the moles of that, then what you do is you just put it into pressures here, and then you'd work out the pressure for each of the gas and then the total pressure. Okay, another method of working out sort of pressures of individual gases. All right, so long method, short method. But remember, this has conditions which I hope you've seen before. Okay, why this works, in what situation does this equality works. Okay, now remember what I said right at the start. I said in my thumbnail that the key to to being successful, I guess, at multiple choice questions is to find quick and simple ways of doing it. That was a quick and simple way. If you started doing this, imagine doing this, yeah, in a multiple choice question. It's going to take you a lot longer than sort of 1 minute, 1.5 minutes. You don't want to spend that time. You don't want to waste that time, because that time you could have spent somewhere else. Okay, and you might not have that time. So find quick and simple. And there's only one way you can do that. Practice, practice, and practice again. Now that I've shown you this method, if this kind of question comes up, that'll be in your head, hopefully. Yeah, you'll think, okay, that might be able to work. P1V1 equals P2V2. Yeah, but if you'd never done this question before the exam and this question had come up, what would you have done? You would have done that way. Yeah, unless of course, some people would have cottoned on, right? Most of the students would have done this. So practice multiple choice questions. When I keep telling you practice exam questions, that includes multiple choice questions. Okay, if you don't practice exam questions, multiple choice questions, you're going to struggle. Yeah, as the best case scenario would be, you might run out of time. Why? Because you've never timed yourself. You never put pressure on yourself. Yeah, you've never done things quickly. You never found those simple and quick methods. Okay. Anyway, if there's any other particular questions that you want me to do, all right, let me know. If you're not subscribed yet, please subscribe and share this video if you think it's useful. And I'll see you next Wednesday. Bye.